Hi there, in this video I'm going to machine the Conrod for the Stuart half beam. Now just to remind myself how to do this, I've just looked back at the video I did for the S50, I think it was part 7 when I made the Conrod for that, and I've decided to follow roughly the same process. Now following my last video, Kevin suggested that it might be worthwhile pointing out that to some of the newbies in this hobby that, you know, I might do a 20 or 30 minute video making a component, but actually it doesn't actually take 20 or 30 minutes to actually make that component. It probably overall takes a couple of days. And just to give some of the people new to the hobby some idea in terms of how long it takes me to do certain things. In reality, it probably takes me 50% of the time just thinking about it and how I'm going to go about making something. I probably spend 20% of the time setting things up on the lathe or the mill, probably more than that actually. Maybe less than 10% of the time actually machining, and probably around about 20% of the time setting up the camera and making the video. So that should give people a rough idea in terms of just how long it takes me to do things. But anyway, like I say, in this video I'm going to have a go at machining the Conrod for the Stuart half beam. So the Conrod is machined out of this piece of mild steel bar, which is 1/2 inch by 5/8. So I've just cut it down slightly, so it's about 1/2 inch oversize on each end. And what I'm going to do first of all is put it in the 4-jaw chuck, centre it on each of the opposite sides, and then I'm going to centre drill each end. Okay, so this has taken me about 10 minutes to centre this up. So we're on 0 here. On the opposite side, on 0, and on this side, let's turn this round. Couple of thou out there, but I think we're okay. So what I need to do now is just to face this end off, and then I'll centre drill. Well, that looks okay. So what I need to do is switch it round in the 4-jaw chuck and repeat exactly the same process on the other side, but I'll do all that off camera. Well, the centre drilling's worked out okay. And I've marked it up. Now the strange thing is, the dimension here reads 1 15/32, and I reckon it put it out here. So I've just recalculated it, because this drawing's to scale, and I reckon it's 1 1/16. So I've marked it up based upon my measurement. Now what I'm going to do is, first of all, I'm going to drill these holes through the sides, and ream them. And once I've done that, I'm then going to drill and machine out the fork bit. But I'm going to leave this piece here intact, because then I'm going to put it between centres. I'm going to use something like that in the 3-jaw chuck. Now then, I've just had a thought. The other week I made this on the 3D printer, and I based it on a design I'd seen on the internet, and I've given credit to the guy when I put this on Thingiverse. It's really simple. Obviously I made this on the lathe. Press that in, it engages with the shaft, and just loosen off. Take that out, put the chuck in, engage it again, it automatically springs out. So if anybody's interested in that design, I've put it on Thingiverse, and I'll put a link in the description. Well, the wiggler's spot on, so I'll replace the wiggler with a centre drill, and I'll just put a mark using the centre drill by turning the chuck, and then I'll move the x-axis along 5 3/32 of an inch, and that should coincide with that mark over here. And again, I'll just mark it with a centre drill and make sure everything's spot on, and if it is, I'll start drilling. Well, I thought I'd get away with using a hand reamer in a chuck, but that didn't work, so I'm taking it nice and slowly now. So on this side I need to drill and ream to 1/4 of an inch. So I've already centre drilled, and now I'm going to drill through with this 6mm stub drill. Okay, so now I need to drill out this fork, and the way I'm going to do this is I've centred on the centre line and also on where the curve comes round here, on the inner edge of the fork. Having centred on that, I've now moved the x-axis 5/16 of an inch and centre drilled at that point. Now I've moved it 5/16 of an inch because eventually I'm going to drill to a diameter of 3/8 of an inch, which will take me up to that edge, and it'll also take me up to the edges of the width of this actual inside of the fork. So now I'm going to drill through with this 6mm stub drill. So I'll work my way up to 3/8 of an inch and then I'll get back to you. Well, that seemed to work out okay. Now this hole is 3/8 of an inch in diameter, which is the exact internal width of the fork. So what I've done now is I've moved the x-axis this way by 3/8 of an inch. So I'm going to centre drill and repeat the same process again. So I'll drill with a 6mm drill bit, then I think an 8mm drill bit, and then finally 3/8, which will put another hole there, and I'll repeat the process again up here until I get close to this end here. But I'm not going to go right out here because I need to leave this bit intact. But I'll do all that off camera and then I'll get back to you. And now I'm going to finish it off by milling. Well, that's turned out nicely. Now what I was going to do was to put it on the lathe and start machining between centres to do this taper. But then I realised that it's probably better to just mill this piece here while, you know, I've got some straight edges that I can put it in the vise. So it needs to be brought down to 5/16 of an inch. So it's currently 5/8 of an inch wide. So I need to take 156 thou off each side. So that's just a simple milling operation. So I'll just mill off 156 thou up to that point. But I'll do all that off camera, otherwise this video is going to be far too long. So the machining on the mill of this end went very well, so I'm happy with that. And I just need to explain this setup. I've got a dead centre in the 3-jaw chuck here, and I've got a live centre here, and I've got a lathe dog here. So the lathe dog will be tightened up and the chuck will drive the piece round. Now my tailstock has got an adjustment on it so you can move it forward or backwards. And I'll be using that to create the taper. But first of all, I want to make sure that it's not creating a taper, if you get my drift. I need to make sure it's dead centre on the bed. And this is a gauge holder that I designed using Fusion 360 and printed it on the 3D printer. And this just is held in the 2-post holder. and I've set it on 0 or thereabouts, and if I just move the carriage down, this should indicate whether or not everything is nice and parallel, and it is. So I'm happy that the centre of the tailstock is spot on centre with the headstock. So what I need to do first of all is to just machine this down to 5/16 in diameter. Once I've machined it down to 5/16 in diameter, I can then adjust the tailstock to put the taper on. Well, I must say I'm a little undecided how best to go about this, but I think I need to take it a step at a time. So what I'm going to do is I'm going to reduce this diameter down to that point there and then have a rethink. Well, I don't know whether this is quite the right method, but what I'm doing here is I'm wiggling the carriage a little bit and moving the cross slide in by about 10 thou. Once I've made that little groove there, then I'm using the power feed to cut the rest. So I don't know whether that's right or wrong, but it seems to be working. So I'm going to aim to get that down to, I think it's 5/16. And once I've got that down to 5/16, I'll use the left hand tool to do the same on the other side. Well, I must say I got a really nice finish using these cutters that are meant for aluminium. Really happy with that. And at the same time, whilst everything was lined up, I decided to just machine these corners off. And I did this using a mixture of that tool, and I finished it off with this round one. And I'm happy with the way that's come out as well. So the idea now is to put these tapers on. So for a bit of maths, that's supposed to be 5/16 of an inch. It's a bit under actually, and the end is supposed to be a quarter, so that's a difference of 1/16 of an inch. Divide it by 2, you get a 32nd of an inch. So I need to move this tailstock that way until I've got a 32nd of an inch difference between that point, the midpoint, and the end. Now a 32nd of an inch is round about 30 thou. So what I'll do, I'll have to do it off camera because I've never actually adjusted this tailstock before. But it's just a matter of manipulating some grub screws so it goes that way. But like I say, I'll do it all off camera and then I'll get back to you. Well, that's a bit disappointing. It looks like I've got to the maximum I can adjust this tailstock that way, and unfortunately it's only giving me an offset of round about 23 thou. So I'm going to have to live with that. So I'll put this aluminium type cutter in and I'll have a go at putting this taper on. So I've zeroised the cutter on that point, then I'll move it back, and then I'll move it in 10 thou or thereabouts. We'll try a cut. I'll be using the fine feed on the carriage. Well, that looks pretty good. Pretty happy with that. .266, well, should be 0.25, but I'll go with that. So what I'm going to do now is try and do this other taper on this side, and I'm not too sure how I'm going to do that. So I can either move the tailstock the other way and then try the left hand tool in here, but then I'm on manual feed. I won't get as good a finish as that. So I think what I'll do is I'll just switch this round and see if I can cut the taper using the same tool. Okay, so I've not adjusted the tailstock, and I've switched the piece round and put it on 0. And if I move it that way, I get 23 thou. So I'm really happy that it's turned round okay. So what I'll do is I'll repeat exactly the same process using this tool. I'll do it off camera because it's exactly the same as what I did there, and then I'll get back to you. Well, I'm really happy with the way that's turned out. The taper isn't identical to the drawing, not as pronounced, but I think it looks okay. Now this particular profile is virtually complete. It's just a matter of taking these ends off. And for this profile, this side is close to completion, just needs a curve on the end, and this needs to be reduced in width, and again a curve on the end. So in order to machine this profile, I've marked it up, and I've made a washer here to be 3/8 of an inch in diameter. I've just held it in with this 8BA nut and bolt. So what I'm going to do now is I'm going to put it on the mill, and I'm going to machine this edge here and that edge and the opposite edges, and just machine round, just to get rid of as much metal as possible, but obviously I need to retain this shape here. Well, this seems to be going okay, so I'm just gradually removing metal and just using this washer as the profile, and I haven't cut it yet, which is good. So I'll just continue milling down here to reduce this, and then I'll switch it round in the chuck and repeat the same process on the other side. Well, after a lot of debating and faffing around, I've decided just to use a hand file to round these ends off. So to turn this other end down, I've made this sort of like spigot thing. So that's 1/2 inch across. It goes right through the small end, I suppose you might call it, and into this collet chuck. And this is held on top of my rotary table. So everything was centred up, and now I've offset the x-axis, and I can just take cuts to about 1/10 out at a time. Well, that was really enjoyable, making that taper, but I was a bit disappointed with the amount of offset I could achieve on my tailstock. And some of you may ask why I didn't use the compound slide. Well, the reason I didn't use the compound slide was I wanted to use the power feed to get a really nice finish, and I did manage to achieve that. I suppose another option might have been to use a boring head, because my boring head has got an MT2 attachment. But what I wasn't sure of, whether or not I'd need a drawbar to hold it in the tailstock. And two problems there. One is I don't have a drawbar, and the other is you can't actually fit a drawbar on my tailstock. So if anybody's sort of any advice in terms of whether or not it would have held without a drawbar, I will be very interested. But all in all, I'm really happy with the result. The only thing outstanding is to make a little bush, which I'll do off camera, and it needs a bit more of a polish up. But overall, I'm very happy with it, and I hope you'll like it too, and I hope to see you later.